This is Math 110, lab number 18. We're going to be solving exponential and logarithmic equations. Let's start off by solving this exponential equation. So when you're solving exponential equations, you use logarithms to solve those. And if the bases are the same, you can use a common log base. If the bases are not the same, you want to use a common log, which would be log base 10 or natural log to do that. So for this problem, we look at the base is a 3, and on the other side we have a 5. So we cannot use log base 3 to solve this one, or we can use the natural log to solve that. So I'm going to work this one two different ways. One way using log base 3 and the other way using a natural log, and show that we get the exact same answer with that. So here we have the base of 3 and that. So I'm going to work with the log base 3 first and go from there. So here I would take the log base 3 of each side. Log base 3 of 5 is a number, so that's what we need to keep in mind. And on the left-hand side, log base 3 and the base 3 cancels out, leaving us 2x minus 1 equals log base 3 of 5. And then we would just work to get x by itself. Log base 3 of 5 is just a number. That means I can add 1 to it. 2x equals log base 3 of 5 plus 1. And then I could divide that by 2. There is x equals log base 3 of 5 plus 1, all divided by 2. And as a decimal approximation, I can hit math, go to log base 3 of 5, right arrow key plus 1, get that answer, divide it by 2, I get 1.2325 if I go 4 decimal places. That's using log base 3 to get your result. If you take the original problem and we solve using natural log, I'll show you that you get the same equivalent answer. So if I took the natural log of each side, it just looks much different. And that allows me to take the 2x minus 1 down to the front and leave natural log of 3. And then I could then take that and divide by natural log of 3. So I have 2x minus 1 equals natural log of 5 over natural log of 3. And then I do the same steps. I add 1. 2x equals natural log of 5, natural log of 3 plus 1. And then I divide everybody by 2. So I have x equals natural log of 5 divided by natural log of 3 plus 1, all that divided by 2. So I can get the decimal approximation for that. So I'm going to do natural log of 5 divided by natural log of 3 plus 1 divided by 2. Again, the exact same decimal approximation. Keeping just a reminder that that part is the change of base formula for log base 3 of 5. So either way works for solving unlike bases for logarithms. Now let's look at this logarithmic equation that has a natural log in there. So it already has a logarithm. So in order to undo logarithms, you use exponentials. So we're going to exponentiate this using the base of the log. Since this is natural log, it's a base of an e. So we're going to exponentiate each side with an e. This side cancels out. Natural log and a base e cancel each other, leaving us 5x plus 1 On the right-hand side, we have e to the fourth power. Now we just get x by itself. E to the fourth power is a number, so we just subtract 1. 5x is equal to e to the fourth power minus 1, and then divide by 5. E to the fourth minus 1 divided by 5. Get a decimal approximation. Second natural log to get the e to the fourth minus 1, and that divided by 5. 10.7196. 4 decimal places. Right. Let's look at example 3, logarithmic equation that has some 2 logs in it that are combined using subtraction. So with this, we're going to use our logarithmic properties. The quotient property says that subtraction problems of like logs becomes a division problem. So we can condense this into a log base 3 of x plus 2 over x minus 5 is equal to 2. And then it becomes a logarithmic problem that we can get rid of the log by using the exponentiation with the base. The base is a 3, so we're going to base 3 on each side. That's going to allow us to have the log 3 and the base 3 cancel out. So that's x plus 2 over x minus 5. The right-hand side is 3 squared, which is 9. And then we can solve this by x minus 5 multiplying on each side. X plus 2 equals 9x minus 45. And then get x by itself or combine like terms. So I'm gonna subtract 9x and subtract 2. So that's going to be negative 8x equals negative 47. And do the division. Negative 8. And I get the fraction 47 over 8. Keep in mind that you need to check the solutions to your logarithmic equations to ensure that you're not taking the log of 0 or a negative number. Make sure of that, and also that you don't have if you end up with a rational expression, one of your excluded values here would be 5 for this one. So if you plug that back in, it does work for this problem. Similarly, for this problem, plug back in the 10.7196. It does work for this problem as well. So always check for extraneous solutions. Math 110, lab number 18.